What's happening, dogs? Mr. Allen here. We're about to solve this lovely rational equation here, and we're going to list any domain restrictions. Now, the first step when solving rational equations like this one here, I got to factor any denominator that has not yet been factored or can be factored here, which would be this bad boy right here. What multiplies to 3 and adds to 4? That's going to be x plus 3, x plus 1, Gucci. Now, fun fact here, it's often these guys right here, or at least some form of them. Maybe there's another one in there, but it's usually at least one of those two in these problems here. Little teacher hint. Okay, anywho, let's continue. So now I got to figure out what my LCD is, my least common denominator. My LCD, I'll jot that bad boy right here, LCD, boom. Well, it's got to have an x plus 3. So that one's good. It's got to have an x plus 1. That takes care of that one. So it looks like x plus 3 and x plus 1, that would be my least common denominator, which also then takes care of my domain restrictions. X cannot equal, well, it can't equal negative 3, it'd make that one 0, and it can't equal negative 1, it'd make that one 0, or either of those 0. So it's going to be negative 3 and negative 1. All right, already took care of that. That's dope, that's awesome, that's rad, dogs, rad. All righty, so there's a couple ways to solve rational equations here. My preferred method is to multiply both sides of my equation by the least common denominator, which allows me to get rid of my denominators, right? My denominators will cancel out. They'll divide out when I multiply each numerator by that LCD. So when I multiply both sides, it multiplies this fraction by the least common denominator, this part by it, and this part by it, all the numerators, right? So I'm going to have x plus 3 times x plus 1. I'm going to have x plus 3 times x plus 1. It gets a little crowded in these things. And then we got x plus 3, x plus 1. It's kind of there. Okay, cool. Beautiful. So, again, it only multiplies the numerators because really I'm multiplying by x plus 3 times x plus 1 over 1. And if you think back to multiplying fractions, the numerators and the denominators get multiplied together, right? So there we go. My denominator is 1. Nothing happens there. All right. That was a fun, dramatic pause. All right. Let's go into some cancellations here. Some people don't like when you say the word cancel in mathematics. Whatever, bro. This guy and that guy divided. Boom. They're gone. Pew. All right. And then here we've got both of them. So this guy's really out of here. Boom. Gone with this guy. Boom. Gone with this one here. Sorry. Sometimes the markers don't show well when they're writing over each other. Hopefully we can see that. All right, and then we got x plus 1's gone. Boom. All right, now let's write some things up that we got. All right, so this one here, I've got 2 times x plus 1. 2 parentheses x plus 1 minus, this one is 3x plus 5. I'm going to throw that in parentheses so that I remember to distribute that negative right there, that subtraction, right? And then here I've got 5 times x plus 3. Beautiful, wonderful, fantastic. Look at that. Fractions, poof, gone. Now I can just solve this little algebra 1 problem. It's medium size, let's say. It's medium. It's not so little. All right, so we got 2 times x is 2x plus 2. And then we got our negative that gets distributed in minus 3x minus 5 equals, and then boom, 5x plus 15. Yeah, wonderful. Let's combine some like terms on this left side before we start moving things around. So I'm going to get negative x minus 3 equals, and we got 5x plus 15. Now I can solve for x. Now if I want to stay kind of positive with my x's, then I can go to the right-hand side with those. But I think most of us like to go to the left-hand side with our x's. So I'll subtract 5x on both sides. I will add 3 on both sides. And now I'm going to have negative 6x equals 18. If I divide by negative 6, I'm going to get x equals negative 3. Now, before I circle, I got to make sure this is in a domain restriction. It is. This is an extraneous solution right here. So really there is no solution to this problem here because there's no other number that's going to work. No solution. That's so sad. We did all that work and there's no solution. All right. But something I like to say in these situations, sometimes we ask you a question on a test, or the SAT or ACT might ask you, which of the following is an extraneous solution? X equals negative 3 is an extraneous solution. Negative 1 is not. It's a domain restriction. But x equals negative 3 is an extraneous solution. So that is a possible question. So you do still need to go through the entire process to get that. Know what your domain restrictions are. And the one that it matches up with the domain restriction is an extraneous solution, which could be the answer on a test, right? But this is no solution for x that would work in the original problem because it would be undefined. That's no bueno. That's sad. But I hope you guys still enjoyed the mathematical experience we just shared with each other. See you later.